Okay. Hello guys. So today we are going to do a problem called maximum subarray problem. Okay. So the problem is maximum subarray problem. Okay. So first let's understand what the problem is. So suppose you are given an array A and it has some elements in it like 1, 2, -3, -4, 2, 7, -2, 3. Okay. Now, so the array contains positive as well as the negative element, and the array is not sorted. So it's not sorted. Okay. Now, what's our job? Our job is to find the sub array of this array which produces the maximum sum. Okay, so for example, what are the sub array of this array? So if you look at this array, we have a different sub array. We have a sub array like 1, 2, right? That's a sub array. Sub array means the ordering of the element, they don't change. Okay, so 1, 2 is one sub array, then we have 1, 2, -3, that's another sub array, then we have 1, 2, -3 and -4, that's another sub array, and then we have 2, 7, -2, 3, that's another sub array. So we have to find the array, the sub array whose sum is maximum. So if you look at this sub array, what is the sum of this sub array? 3. If you look at this one, the sum of this one is 0, and if you look at this one, the sum of this one is -4. And if you look at this one, the sum of this is 9, 12, and so that's 10. So you have to find the subarray whose sum is maximum. Okay, so for this array, the output is 2, 7, -2 and 3, that is equal to 10. Okay, so you have to return the sum, so you have to return number 10. Now I'm going to show you two approaches for this problem. One is dynamic programming approach and the another is Cadence Algorithm. Okay, so let's look at the first approach, dynamic programming approach. In that approach, what you are going to do is you are going to maintain an array which is of the same size as the given array. So what is the size of the given array? It's 6 and 8. Okay, so you'll create one solution array of the same size as the given array, which is 8. Okay, so you'll have first element in the solution array same as the first element of the array. Okay, now for the second element. Okay, what does this mean? Each index position in the solution array means the maximum sum that we have found for the index which is ending here. Okay, so the maximum sum for the index which is ending here, that is 0th index, is 1. Now at index 2, what is the maximum sum? So for that, what you are going to do is you are going to do 1, and in the previous solution I minus 1, what is the value of I minus 1? Solution of I minus 1, which is 1, plus 2, and you will see 3, and then you will see 2, the element itself. Okay, which one is max out of this 2? So let me write it this way. So you are going to pick math.max, okay, of solution array of I minus 1 plus a of I, comma a of I. Okay, So that's what you are going to do. So for the second element, the solution of I minus 1 is 1 plus 2 and a of I is 2. What is the max? 3, of course. So the maximum sum that we have found here at index 2 for the subarray which is ending at index 2 is 3. Okay. Now for the next index, which is 2. Okay, we have minus 3. So what we are going to do is we are going to do solution. So a solution of I minus 1, that is 3 minus 3 and minus 3. What is maximum? Here, of course, 0, right? So the maximum sum for the index which is ending here, doesn't matter what the start index is, but for the index which is ending here, the subhead, it ends here, the maximum sum that we have found is 0 at this index. So that means you use all this 3 element and you get 0, because that's the maximum sum that you can get. Now we have minus 4. Okay, so now what we are going to do is we are going to do 0 minus 4, 0 minus 4 and minus 4. What is the max out of this two? Minus 4. Okay, so here we have minus 4 as the answer. The max sum that we can get here is minus 4, because look here, if you use all this element, okay, so that will be minus 4, and if you take just this element, it will be minus 4. That's the max sum you can get. Or if you take just this 2 element, then a minus 4 minus 3, that is minus 7. If you take this 3 element, then also it's minus 5. So, and if you take all this, it's minus 4. Next index, which is 2. Okay, so what we are going to do is minus 4 plus 2, minus 4 plus minus 4, that is that, and minus 4 is the previous element, plus 2, and then here 2. What is the maximum? Of course 2. So here we are saying that the maximum sum we can get is 2. I mean, if you include this element, the sum will be less than 2. So that's the maximum sum we can get. Okay, now for the next index position, 2 plus 7 is the maximum sum that we can get, which is 9. And for the next index position, we can get 9 minus 2, 9 minus 2 and minus 2. What is the maximum sum we can get, which is 7. And for the next index position, 7 plus 3 comma 3, so the maximum sum we can get is 10. So 2, then 9, then 7 and 10. And once you are done populating this solution array, you just have to take max out of this array, and the max out of this array is 10. So the max sum we can get using the subarray is 10. Now what is the time complexity of this solution? We are traversing the array only once, so the time complexity is O of n. What is the space complexity? We are using an extra space to create a solution array, so the space complexity is O of n. Okay, and now let's implement this approach. Okay, so the first thing we will write is public integer find max sub array. And what we are given? We are given an integer array A. That's all we are given. And what we are going to do here is we are going to create a solution array. So integer, we are going to do a solution array which is of the same size as the array. So A dot length. And after that, the first element, the max that you can get at index 0 is the element itself, okay, which is array of 0. Okay, that's the max you can get. Now we'll do a for loop for integer I is equal to 0. 0 is already done, so I is equal to 1, I less than a dot length and I plus plus. Solution of I is equal to math dot max solution of I minus 1 plus a of I comma a of I. Okay, so we are done with the for loop, and then we have to find the maximum out of the solution array. So the max is equal to solution of 0. We'll scan the array and find the maximum. So for integer I is equal to 0, I less than a dot length I plus plus, and if solution of I is greater than max, then update max. Max is equal to solution of I, and we are done with this for loop, and we are going to return max, and we are done. So this solution has O of n time complexity and O of n space complexity. Now the second solution that I'm going to show is Cadence algorithm. Okay, now what this solution has is the time complexity of this solution is same as the previous solution, which is O of n, but the space complexity of this solution is O of 1. We are going to use exactly the same approach, okay, that we have used using the DP approach. So let me write the array again. We have array 1, 2, minus 3, minus 4, 2, 7, minus 2 and 3. Okay, so now what we are going to do is we are going to, instead of using the solution array, we are going to maintain those max which are ending at each index position in a variable, and we'll also maintain one more variable, that is the maximum sum that we have found till now. Okay, so what we are going to do is we'll have two variables. Okay, one is max end here and another is max sum. Okay, so first of all we'll go here, the first element. Okay, the max end here will be 1 at this element. Okay, so the max end here is 1, the maximum ending at that index position is 1, and the max sum is also 1. Then we go to the next element, which is 2. So what is the max end at that position? So it would be the max end, whatever the value we have in the max end here, which is 1, so it would be math, do this so that you can see. So it would be math dot max, the max end here, which is 1, plus the current element or the current element, whatever the maximum is. Okay, so what is the maximum? It's 3. So we'll update the max end here, max end here plus that one. So it would be max end here. So it would be math dot max of max end here plus the previous element. Yeah, it would be math dot max. So yeah, it would be the max end here is 1. So 1 plus 2 will do, which is 3, and then 2. What is the maximum? The 3 is maximum. Okay, so we are going to update the max end here to 3. So we have updated this to 3, and we'll also update the maximum, because every time we update the max end here, we'll check that is it greater than the maximum. If it's greater than the maximum, then update the maximum. So we'll update the maximum. Now for the next element, which is minus 3. Okay, so for that, what we are going to do is we are going to see what is the max end at the previous position, which is 3. 3 minus 3 is 0. So 0 and minus 3, what is greater? 0. So we'll update the max end here to 0, and we'll check, is max end here greater than the maximum? If it's greater than the maximum, then update the maximum. But it's not greater than the maximum, so we will not worry about updating the maximum. Then comes minus 4. The max end here is 0. So 0 minus 4 is minus 4, and minus 4 itself, what is the max? Minus 4. So we'll update the max end here to minus 4. And then again we'll check, is it greater than the maximum? If it's greater than the maximum, then we have to update the maximum, but it's not. Then comes 2. So minus 4 plus 2, which is minus 2 and 2. The maximum is 2. So max end here becomes 2. Maximum is greater than the max end here? No. So we are not going to update the maximum. So till now we have the maximum we have found is 3. So now comes 7. So 2 plus 7 is 9, and 7, what is greater? 9. So we'll update the max end here to 9. Now the max end here is greater than the maximum, so we'll update the maximum to 9. Now the next element is minus 2. So 9 minus 2 is 7, and minus 2, what is maximum? 7. So max end here is 7. We'll see, is it greater than the maximum? Nope, it's not greater, so we'll not update the maximum. Now the next element is 3. So 7 plus 3 is 10. Between 10 and 3, what is greater? 10. So we'll update max end here with 10. Now we'll see, okay, max end here is greater than the maximum. So we have to update the maximum, which is 10. So at the end, the maximum will hold the value of the maximum subarray, the subarray whose sum is max, and it will hold that sum in it. Okay, so let's implement this approach. Okay, so we'll do public integer find max subarray, and what we are given is we are given integer array A, and we are going to use two variables. One variable is max and here. Okay, we'll initialize it with the first element of the array, and another variable that we are going to use is maxsum. We are also going to initialize it with the first element of the array, and we are going to start with the first element because 0th element is already done. So I is equal to 1, I less than a dot length, and I plus plus. Okay, so now max and here, okay, at index position 1 is the previous max and here plus a of I and a of I, whatever the maximum is between these two. Okay, so we have to pick the maximum out of this two, and then we are going to check, is that greater than the maximum? Then update the maximum. Okay, So max sum will always be math dot max of max sum, whatever the maximum is, max sum or max, and here. Okay, so that completes our for loop, and what we have to return is we have to return max sum, and we are done. So this is the best approach. Cadence algorithm is the best approach to solve maximum Subarray problem. The time complexity of this approach is O of n, and the space complexity is O of 1. You cannot do better than this. So that's the best approach. Thank you so much for watching the video.